This lesson is on solving systems by elimination. This is our third and final method for solving systems of equations. We've previously learned how to solve by graphing and substitution, and today we're going to take a look at elimination. So our essential question for today's lesson is, how do you solve systems of equations using the elimination method? So before we even get into it, think a little bit about the vocabulary. Think about the word elimination. What does it mean to eliminate? That usually means to get rid of. So this is probably going to have something to do with canceling something out. So before we get too deep into it, let's take a look at our main ideas and questions. So elimination method itself is a method for solving systems of equations by adding or subtracting to eliminate a variable. So I know that they use these words adding or subtracting. Technically, you can do both. Truly, when I teach it, it's going to be more focused on actually adding the two equations together. But we know that if you add a negative, it ends up being subtraction. So you'll see what I'm talking about in just a moment. There are a couple steps to solving. So let's fill in the step by step so you always have a process when you're approaching it in this method. Step one to make sure your equations are lined up. So kind of think of when you're like adding numbers. So if I was adding 234 plus 27, I'm going to make sure that my ones are lined up, my tens are lined up, and my hundreds are lined up. That's like some really old school elementary stuff. When we're adding two equations, we've got to make sure that our x, so for example, our x variables are lined up, our y variables are lined up, the equal signs are lined up, and the constants, the numbers without any variables next to them, are lined up. So when they say make sure the equations are lined up, this is what they're talking about. Your constant has to be over the constant, equal over the equal, y over y, x over x. That's very important. You cannot use this method if one equation's in one order and the other is totally jumbled up. Now, it doesn't have to be in this order. They could be y equals 2x plus 7 and y equals 3x minus 4. We'll see our constants are lined up, our x's are lined up, our equals are lined up, and our y's are lined up. So all that matters is that the common terms are over each other. You're either going to add or subtract the equations to eliminate the variable with common coefficients. Usually we default to the idea of adding them. It just makes it more simple. If you think about subtracting, it gets really confusing. Step 3 is going to be to solve for the remaining variable. Step 4 is to substitute the answer. So, for example, if we find out what x is equal to, we'll plug it back in to find for y. If we find out what y is equal to, we'll plug it back in to find x. And obviously, that's what I'm talking about when I say solve for the other variable. So, make sure they're lined up, add them together, and make sure something cancels out. Solve for one of the variables, substitute back in to solve for the other variable. So, let's look at our first example. So in our first example, I want to approach these problems making sure that they are lined up perfectly. So we've already discussed our y's being over our y's. That's happening here. Equal over equal. That's happening. X term over x term. That's happening. And the constants are also lined up. So it's all lined up perfectly. In order to do elimination, what we want to accomplish is we want something to eliminate. So when I add, I want something to cancel out. I want it to be a zero pair. I want it to disappear. Well, right now, currently, the way it is, if I were to add these two equations, I would have 1y plus 1y equals 2y. The equals, obviously, is just going to stay in equals. 3x plus 1x is going to give me 4x, and 4 plus negative 2 is still going to give me a positive 2. So nothing canceled. What we're hoping to accomplish is to get rid of either the y variable or the x variable, because we talked about in the substitution lesson that I can't actually solve for a variable unless it's the only one in the equation. Well, unless I make something cancel out, I can't solve for either y or x because now they're both still in my equation. So we're going to try and determine how we could make something cancel. You can choose which variable you want to make cancel. If we want to try and make y's cancel, in order to make the y's cancel, one would have to be positive and negative of the same coefficient. Well, they're both 1s, but the problem is that they're both positive. I need to pick either the top or the bottom equation and make one of these y's have a -1 coefficient. Just because I feel like it, not because it's the only decision, I'm going to make the bottom equation have a -1 coefficient. In order to do that, to multiply a positive 1 by something to make it a -1, I'm going to have to multiply by a -1. But when I do that, I can't just multiply y. I have to maintain equivalence. I have to make this a whole totally equivalent equation. So I have to multiply the entire second equation by a -1. So I have to use that distributive property and distribute this -1 to all three terms here. The first equation is remaining unchanged. It will remain a positive 1y equals 3x plus 4. But now the second equation, a -1 times a positive 1, is going to give me a -1y equals -1x, and a -1 times a -2 is going to leave me with a positive 2. So we made that happen. We chose that. It's not the only choice. It was just one of the wisest choices, the easiest choices. So we're still technically adding these two equations. They're still lined up. When I do a 1y plus a -1y, it cancels. So I don't have any y's left. So 0 equals 3x plus -1x leaves us with 2x. And a 4 plus 2 is going to give us a plus 6. Now we have an equation that we can solve for the x variable because x is the only variable in this equation. In order to do so, I would first minus 6 from both sides. And -6 equals 2x. Divide by 2 on both sides. And our x variable is -3. Well, if we remember, we are actually still trying to find a point of intersection. So if -3 is the x-coordinate, we still need to find the y-coordinate. In order to do that, we can plug that back into either one of these original equations. Technically, you can also plug it back into the equivalent form of the equation. I would probably stick with one of the originals just because they're usually not too bad, but I just want you to know that officially you could plug it into the new one if you did it correctly. So I'm going to pick one of the original ones just because I feel like it. I'm going to pick the second one. It just looks easier. So the second equation was originally y equals x minus 2. I'm going to plug in this value for x. Y equals -3 minus 2. I think I said plus earlier. Sorry, that was my mistake. So -3 minus 2, y equals a -5. So now I have a x value and a y value. So the ordered pair where they intersect is the point -3, -5. This is just, like I said, the third and final method of trying to find the point where these two lines intersect. It would be the same answer whether or not I chose to graph these two equations, to use substitution, or elimination. So that is our solution. There's one solution, and the official solution is the point -3, -5. So let's try another one. So on this one, I have more than one option. Anytime that I'm approaching a problem and I want to use elimination, again, I do need to make sure that the x terms are over the x terms, the y terms are over the y terms, the equal signs are lined up, and the constants, the numbers without variables, are lined up. That is happening here, so I don't have to shuffle or rearrange either of my equations. But if I chose to try and add these right now, nothing would cancel out because I'd have a 1 plus 1 equals 2x, 4 plus -1 equals 3y, and I still have an x and y in my equation. I need to try and make either the x's cancel out or the y's cancel out. If I wanted to choose the x's to cancel, right now they both have a +1 coefficient. In order to make them cancel, I could do what I did last time, and I could multiply either one of them, whether I chose the top or the bottom. I could multiply by a -1. I could also multiply to cancel out the y's. So right now I have a positive 4y and a negative 1y on the bottom. If I wanted the y's to cancel this time instead, I could choose to multiply the bottom equation by 4 because the top is already a positive 4, so I need the bottom to be a negative 4. Well, it's already a negative 1. In order to make negative 1 into a negative 4, I simply need to multiply by a positive 4. So we're going to try that approach this time just to see what happens. So instead of just doing the easy way, which honestly is the x's, I could just multiply by a negative and make the x's cancel. I'm going to make the y's cancel just to prove to you that you can do either method. So I'm going to multiply the bottom equation by a positive 4. When I do that, I have to maintain this distributive property. It has to go to all three terms inside of the parentheses. A common mistake is that students will multiply by the x and y coefficients and forget to multiply by the constant. It has to go to all three terms. So our first equation is remaining unchanged. We have a 1x plus 4y equals 13. Our second new equivalent form of the equation is going to be 4x minus 4y equals 4 times 13. 4 times 3 is 12, 4 times 1, so 52. And now we are still technically adding these two equations. They're lined up. We're going to see what we get. So a 1x plus a 4x gives us 5x. A positive 4y minus 4y completely cancels out, which is technically like a plus 0, equals 13 plus 52 leaves us with a 65. So we're looking at 5x equals 65. So when I divide both sides by 5, I find out that the x variable is equal to 13. Again, if I have an x coordinate, therefore I must have a y coordinate because I'm looking for a point of intersection. So I'm going to plug that value for x back into either one of the originals. It truly does not matter which one. This bottom one looks a little bit easier, so I'm going to attempt that one. So I'm going to use the x minus y equals 13. I'm going to plug that 13 where x is. And I've got 13 minus y equals 13. When I minus 13 from both sides, I get negative y equals 0. And even though negative is in front of y, when I divide a negative 1 on both sides, 0 over negative 1 is still 0. So my y coordinate is 0. So the actual solution, there's one solution, there's one spot where these two lines intersect, and that's happening at the ordered pair 13, 0. That is the answer to the problem. All right, we'll try one more before you go off on your own. So we've got on number 3, 3x minus 10y equals 14. 3x minus 9y equals 15. Again, I could try and make the y's or the x's cancel. It doesn't matter. Mathematically, if you follow the rules, you do what you're supposed to do. You can make the x's cancel first, or you can make the y's cancel first. What matters is I want to make sure my equations are lined up before I start doing anything. The x terms are over each other, the y terms are over each other, the equal signs are lined up, the constants are over each other, so I'm good to go. I just need to choose which one I personally feel like is the easiest choice to make cancel. I can make the y's cancel, but it's clearly going to be more work. Y has a negative 10 in front of it, and the other y has a negative 9 in front of it. I can't make 9 into 10 or 10 into 9. It's a little bit difficult. I would have to multiply both equations to make this to be a common factor of 90. It's a lot more work, and we're going to talk about it in a second, because sometimes it's your only choice. But this time, I see that x has the same coefficient. They both have a 3 out front. The only issue right now is that one's positive and the other one's also positive. In order to make them cancel out by addition, at least one of these has to be negative. Well, because I keep showing you the second one being multiplied, this time I'm going to just, to prove a point, show you that you can also multiply the top equation. It doesn't matter. You're just trying to decide which one you want to make cancel. So if both of them are positive, I just need to pick one of them to make negative. In order to make a positive 3 into negative 3, I simply need to multiply by a negative 1. So I'm going to multiply this entire top equation to maintain equivalence by a -1. I will distribute that -1 to all three terms in the original equation. That will leave me with a -3x plus 10y equals a -14. I did not make any changes to the second equation, so I will rewrite it the way it was. And now I will continue to actually add, because now something's going to cancel. A -3x plus 3x will leave us with 0x, so there's no x's left. 10y plus a -9y just really means 10 minus 9, so there's a +1y left, equals -14 plus 15 is the same thing as 15 minus 14, which is a +1. So we've got our y variable. We need to find our x variable. So we're going to choose to plug that into either one of these original equations. I'm going to pick the bottom one just because I feel like it, not because it's the only one. So I've got 3x minus 9 times y equals 15. We now know that y is equal to 1, so I'm going to plug that in where the y was. 3x minus 9 times 1 is just 9, equals 15. To solve for x now, I'm going to add 9 to both sides. And 3x equals 9 plus 15 is 24. Divide both sides by 3 because it's being multiplied by x, and x equals 8. I have to make sure I write my answer in order. It's x before y, so the actual answer to where these two lines intersect is the point 8, 1. So that is our solution to the problem. Sometimes we're fortunate enough where they already line up and cancel out, and we don't have to do any work. The first three that I showed you, you had to, at a minimum, make one of the coefficients negative. You had to at least have a positive and a negative coefficient. Sometimes we might be lucky enough to get two equations where one of them's already positive and one of them's already negative. When that happens, you don't have to do this extra work of distributing a number. You can simply go ahead and add and something will cancel. So I want you to go ahead and try the next few questions, see if you get them right, and even if you don't, you will still have a chance to come back and look at how to solve them and clarify any misunderstandings.